Hey everybody, welcome to another con support video. This one is on combining like terms with negative numbers and distribution. So let's go through and see how this goes. Okay, the first example here that we have is 8k minus 5 times the quantity of negative 5k plus 3. So the first thing I'm going to do is I'm going to write it over here for us so we have a good copy of it. And so that's going to be, let's see, there we go. Let's do it as 8k and then minus 5 times the quantity of negative 5k plus 3. Okay, so what you're going to do here is you're going to distribute first. So whenever you see something touching a parentheses like this, where you have a number outside, you got a sum or a difference inside, then we're going to want to distribute algebraically so that we can start to combine like terms. You never combine like terms while things are still stuck inside the parentheses. Because what this really means is I've got 8 positive k's, and I've got the opposite of 5 groups of all of this. And so in order to figure out what all this is really worth, we have to actually distribute, multiply through by that outside factor of negative 5. So the first step in this problem is to take this negative 5, and not just the 5, but a negative 5, and distribute. Let me move myself over a little bit. There we go. So you're going to go, okay, I'm going to take this negative 5, and I'm going to multiply through the parentheses by the negative 5, multiplying each term inside the parentheses by that negative 5. That's the distributive property. So ultimately what you get here, if we write out all of our steps, is ultimately you get this. You get 8k, I'm going to do that in black, 8k minus, or I should say, plus, and then you've got negative 5 times negative 5k, so it'd be negative 5 times negative 5k, and then you're going to add to that negative 5 times a positive 3. So that would be plus negative 5 times positive 3. That's the distributive property. You take that negative 5, you multiply through the parentheses, just like I'm showing you with that rainbow. Negative 5 times negative 5k plus negative 5 times positive 3. Now, ultimately, do you always have to show this step? No, most of the time we do that step in our head, but I want you to see what you're actually doing there. Okay? And then we just kind of go through it like normal. So remember, the pluses and minuses outside of parentheses are separators. So really, this is just 8k. And then you're going to multiply negative 5 times negative 5k. And what is a negative times a negative? Positive. So ultimately, this is like plus, right? That stays the same. And then you got positive 25k. That's 5 times 5 is 25. So we have plus 25k here. And then you're going to add to that the product of negative 5 and 3, which is negative 15. So ultimately, what you're really looking at is 8k plus 25k plus negative 15. And now that we've broken everything out of the parentheses, right, it's all free, and we have just our terms laid out in front of us. There's no more parentheses kind of holding things in, or we got to figure out the values that are there, really. Now we can combine our like terms. So now we're going to look for all the k's to be combined, all the constants to be combined. So I'm going to highlight our k's. I think it's pretty obvious. You got 8k, and you're adding to that 25k. Now, I like to this point, I think you guys are probably hopefully comfortable enough that you realize that plus and negative is the same as take away 15, right? So I call that true sum, and it's one sign in front. If you wanted to still use addition and think of it as addition like this, that's obviously fine too, right? This is 8k plus positive 25k plus negative 15, right? And so I'm going to combine these two k terms, right? These are our like terms. Remember, definition of a like term is any term that has the same variable to the same degree. So let's combine our k's. So what's 8k plus 25k? Well, it's really how many k's? 8 plus 25, right? So 8 of them plus 25 of them. How many k's do we have? Well, we have 33 k's. So there are 33 k's here. And so that's what we're going to write. We're going to write 33k and then plus negative 15. Now remember, plus negative 15 is exactly the same as take away 15, okay? Because if you add a negative 15, right, if you wanted to change addition to subtraction, you just change what was being added to its opposite, right? So plus a negative 15 is the same as take away a positive 15. But the way I really think about it is what's a positive times a negative? Negative. So really, if you wanted to write this in simplest form, what this really is, if you just get rid of all the excess stuff, it's just going to be 33k minus 15. And that's it. And that's your answer. Now, as we get more comfortable with the idea of true sign and this idea of imaginary plus sign between each term, I'm going to write less steps out. But I want you to see the whole process from beginning to end and connect it to what you've already done. So looking for our answers here, which is the correct answer? 33k minus 15. There you go. Let's do the next one, okay? So let's scroll down here. I'll do the next one and see how we feel. So the next one is 19 minus 6 times the quantity of negative k plus 4. Okay? So you're taking away 6 groups of negative k, 1 negative k, and 4 positives. That's what this really means. So you're taking all that away from 19. So in order to figure out what the real values of everything is, we have to distribute to get kind of things broken out of that parentheses and find out how many of the things we actually have. So let's investigate that by distributing. Remember, you're multiplying through by this negative 6. So that's the rainbow you should draw. Circle that negative in front of it and multiply through the parentheses. There's your distributive property. So what does this really mean? Well, it means that you have 19 and you are taking away, or if you want adding, if you want to just kind of keep it consistent, adding negative 6 times negative k. And then you are adding negative 6 times positive 4. Okay, so let's do our little math here. We got to do order of operations, right? We got our 3 separate terms here. 19 is a term, negative 6 times negative k is a term, and negative 6 times 4 is a term, separated by these addition signs. Very good. Let's go through and combine our like term, sorry, I should do our order of operations, right? So we can find out the values of each of these things. So what is negative 6 times negative k? That's positive 6k. What is negative 6 times positive 4? That's negative 24. So ultimately what you have here is you have 19 and you're adding to that positive 6k and negative 24. And the shortcut that you would eventually use once you get more comfortable is this. You just go negative 6 times a negative k is a positive 6k. Negative 6 times a positive 4 is a negative 24. And you just kind of combine it all with addition. All right, so now we get to this point here. We're going to combine our like terms. Remember, like terms by definition are terms that have the same variable to the same degree. So when I'm looking at these, I see that you've got 19 as a constant and you've got negative 24 as a constant that you're adding to that. Okay, I see that we have one term that's on its own that doesn't have anything to combine with, and that's a k. So we only have 6k, that's it. There's no other terms that have k in it. So we're going to put together our constants, and we're going to leave that 6k as just 6k. So the ultimate answer here is going to be 6k, and then you're going to add to that the sum of 19 and negative 24. What is 19 plus negative 24? Well, they're going different directions, so who's going to win? The negative by how much? 5. So this is really plus negative 5, right? But like I told you guys before, you only need one sign in front because everything gets added together once you have one sign in front. So this is not necessary to have plus negative 5. Plus negative 5 is the same as take away 5. What's positive times negative? Negative. So this is really the same as 6k minus 5 in simplest form. And so that's the answer you're looking for, 6k minus 5. Okay? Oh, this one's got double distribution, right? 2 distributions that we have to do. So now I think you guys have seen me do it like the long, slow way twice. I'm going to do this a little more efficiently for you now so that you get used to it. So let's copy this problem down and let's see how we can do it, get more comfortable. So for number 3 here, we've got negative 3 times the quantity of 2 plus 4k. And we're going to add to that 7 times the quantity of 2k minus 1. Okay? First thing you want to realize is you're going to multiply through by the outside factor in front of the parentheses. So this negative 3 times the quantity of 2 plus 4k, You got to multiply through by that negative 3. So there's your distribution right there. And then on the other side here, we're going to do the positive 7 multiplied through. So that's just going to be distributed just like that. And we're going to then combine everything at the end. So what is a negative 3 times a positive 2? That's a negative 6. What is a negative 3 times a positive 4k? That's a negative 12k. What is a positive 7 times a positive 2k? That's a positive 14k. What is a positive 7 times a negative 1? That's going to be a negative 7. And now you have everything done the way I would normally do it, simply and clearly. So it's basically the same as we did before, right? Except I just did one step in my head there in the middle there. When I distributed mentally. I kept the one sign in front. And now we can go through and combine our like terms, right? So k's with k's and constants with constants. So let's find our k's. So looking at this, we've got negative 12k, sign's always kept with it on the left, and positive 14k, right? Our other terms that we have to combine here are going to be, let's do something different than pink, let's do green. It's going to be negative 6 and negative 7. So all of these are being added together. There's like imaginary plus signs between all of these terms. When you have one sign in front, right, that's the true sign. That's the real direction that things are going, and they're all being added together, okay? So now we can just kind of combine things. So this is going to be a negative 12k plus 14k. Who's going to win? Positive by how much? 2k. So we know the answer there is 2k. So I'm going to just kind of rewrite that with a yellow, 2k. And then you've got negative 6, and we're adding that to negative 7. Well, that's going to get more negative. How negative does it get? Negative 13. Okay, so ultimately the answer here is just 2k minus 13. And that's how I would do it once I get more comfortable, right, where I'm not showing the extra steps. So I would still show the distribution, right? But then I would just have one sign in front of each thing, knowing in my head that that this is all being added together. That negative 6 subtract 12k plus 14k subtract 7 is exactly the same as when you change your subtraction to addition. Negative 6 plus negative 12k plus positive 14k plus negative 7. That's identical, right? It's just that I don't have to rewrite it changing my subtraction to addition, because I know that if it has one sign in front on the left of each term, then that's the direction it's going, and it's all being added together. All right, so I get 2k minus 13 is my answer. Go over here, 2k minus 13, and I'm good to go. And then last problem is negative k, take away the quantity of negative 8k plus 7. Let's do that one. I'm going to do that the more abbreviated way that I would normally do the problem, okay? So let's just scroll down, and you guys can see this process from beginning to end. So here we have negative k, and you are taking away negative 8k plus 7. So now we have to distribute the negative through the parentheses. Now you might be thinking, well, what is that negative? If you want, you can put a negative 1 there. It's just negative 1 times the quantity inside, right? You're subtracting these values inside. So you're taking away negative 8k, you're taking away positive 7. You're taking away everything inside this parentheses. So this is going to be the same as if you multiply through by that negative 1 times a negative 8k, and negative 1 times a positive 7. So ultimately what you get is negative k. Negative 1 times a negative 8k is positive 8k. Negative times a negative is a positive. And negative 1 times a positive 7 is a negative 7. So this is your result after you distribute. Once you're done distributing, then you're going to combine your like terms. When there's no coefficient in front of a variable other than the sign, positive or negative, that means it's an assumed 1. So this is like negative 1k. So ultimately what we have here, if we combine our like terms, is we have negative 1k plus positive 8k. Well, how many k is that? Well, that's going to be 7k. Because you're going a tug of war, who wins? Positive by how much? 7. So this is going to be positive 7k. And then you're going to just take away the 7. It just comes along for the ride. Nothing really happened to that. So it's just right there. Take away 7. If you want, I could like color code it and make it pretty and do the term thing, but it's not necessary, right? I think you guys get this idea that that's negative 7. It just stays negative 7. So what's its value? And you're just going to do negative 7 there. So ultimately, this whole thing is worth 7k minus 7. And I know that's right. Now, if I was on a test and I was like, you know what, I don't know if I got that right, I want to check it. The way you can check any algebra problem is by plugging in values for the variables, right? So what I'm saying to you when I tell you that this is worth 7k minus 7, I'm saying that these two things are equivalent. That this original algebraic expression that you're given is equivalent to this final algebraic expression that you're given. So let's just say, hypothetically, I wanted to check this on my own on a test before I turned in the test. Couldn't I just pick a value for k? Couldn't I say, like, let's set k equal, let's say, 2? And just check and see if the original value has the same value as the final value, or the original expression has the same value as the final expression? Let's find out. So that would be negative the quantity of 2 minus the quantity of negative 8 times 2, and then plus 7. So I'm going to write that all out, close parentheses. Well, what's that really worth? We can see that it's going to be negative 2, and then inside the parentheses, negative 8 times 2 is negative 16, and negative 16 plus 7 is going to be what? Negative 16 plus 7, negative wins by how much? 9. So what you have here is negative 2 take away the quantity of negative 9, because negative 16 wins, so negative wins by 9. And then we can just kind of look at this and go, all right, negative 2 take away negative 9. That's the same as negative 2 plus 9. Who's going to win that? Positive by how much? 7. So what is the value of the original expression if we were to choose a value of 2 for k? It would be worth 7, right? So this original expression would be worth 7. Cool. The final expression I have should also be worth 7, right? Let's check it. So this should also be 7. 7 times 2 minus 7. Well, that's just going to be 14 minus 7, which is very obviously what? 7. So the original and the final both have the same value of 7 when at k is 2, which means that they should be equivalent expressions. It works. Now we can, of course, hit check here and see that it is right. Okay, but if you were on a test and you were trying to find a way of double checking this yourself, that would be a way you could double check it yourself. All right, so that's it. That's how you do that problem, and hopefully that helps you guys.